I'm going to go through the answers to exercise 3 on page 8. The first one is Li+, so lithium after losing one electron. When lithium loses one electron, it has the same electron configuration as helium, or you can just write this as 1s2. Typically, we don't actually use this shortcut here because there's no need for a shortcut when all you're writing is 1s2. The next one, chlorine. Chlorine has gained one electron. If I go to the periodic table, the noble gas in the period above chlorine is neon, so I write down neon. And then chlorine is now going to have a full third shell, so it's going to have 3s2, 3p6. Magnesium. When magnesium loses 2 electrons, it ends up with exactly the same electron configuration as neon, so I can just write this down as neon. Then I've got vanadium losing 2 electrons. When vanadium is an atom, its outer shell has 2 electrons in the 4s and 3 electrons in the 3d. When it's an ion and it's losing electrons, it doesn't lose them from the 3d orbital, even though the 3d filled last. It loses them from the 4s orbital. So when it's got 2 electrons to lose, they're both going to come out of the 4s orbital, and vanadium is just going to be left with 3d3. You don't even need to include the 4s. With scandium, scandium is here. If scandium loses 3 electrons, it ends up with the same electron configuration as the noble gas in the period before it, which is going to be argon. Next up, I'm going to go through the answers to exercise 4 on page 9. The first one, state how many electrons the following can hold. Anytime you're asked about an orbital, the answer is going to be 2. It doesn't matter what orbital, orbitals can only hold 2 electrons. So a 3s orbital holds 2 electrons. The 4p subshell, 4p subshell is made up of 3 different p orbitals, a 4px, a 4py, and a 4pz. Each of those p orbitals can hold 2 electrons. You've got 3 orbitals. The total number of electrons is 6. The n equals 4 shell, if you scroll up to the table on the page above, the 4th shell has an s orbital, 3 p orbitals, 5 d orbitals, and 7 f orbitals. Each of those orbitals can hold 2 electrons. So if you add up the number of orbitals you've got in the 4th shell, you will see you've got 16 orbitals. They can each hold 2. That gives you a total of 32 electrons in the 4th shell. For the 4d orbital, again, it's an orbital, so the answer is 2. For n equals 3, the 3rd shell, you've got 1s orbital, 3 p's, and 5 d's. If you add those up, you'll see you've got 9 orbitals in total. Each can hold 2. You've got 18 electrons in total. The last one here, the 4f orbital, again, it's an orbital. It can hold only 2 electrons. The next question asks you how many orbitals are in the following. So in the second shell, how many orbitals do you have? In the second shell, you've got 1s orbital, you've got 3p orbitals, so you've got 4 orbitals in total. How many orbitals do you have in the 4th shell? You've got 1s, 3p, 5 d's, and 7 f's. In total, in the 4th shell, you've got 16 different orbitals. How many orbitals are in the 3rd shell? You've got 1s, 3 p's, and 5 d's, so you've got 9 different orbitals in the 3rd shell. And in the 1st shell, you've only got an s orbital. You've got 1 orbital in the 1st shell. The next question, how many subshells are in the following? So n equals 2. When I'm talking about subshells, I'm just talking about the s, p, d, and f orbitals. So how many subshells are in the second shell? In the second shell, you have got a 2s and a 2p, so you've got 2 different subshells present. In the 4th shell, you've got a 4s, a 4p, a 4d, and a 4f, so you've got 4 different subshells present. In the 3rd shell, you've got 3s, 3p, 3d, so you've got 3 subshells. And in n equals 1, you've only got 1 subshell. So the n number matches the number of subshells that you have got. If n equals 2, you've got 2 subshells, s and p. If it's 4, you've got 4 subshells, s, p, d, f, and so on. Question 4, I've already written out the answer. So you're asked to write the electron configuration using no shortcuts. For the first one, carbon, okay? I've already written it out for you, but I just want to show you some checks that you should do to make sure that you are right, okay? So carbon's got 6 electrons. So the first thing to do is make sure that these numbers add to 6. 2, 4, 5, 6. Okay, the second thing you need to do is make sure that your electron configuration lines up with the periodic table. So in the periodic table, we can see that carbon's in group 4 and it's in period 2. That means carbon should have 4 electrons in its outer shell. So it's got 2, 3, 4. Remember, all of the 2s are the outer shell. It's got 4 electrons in its outer shell, and it's got a total of 2 shells. It's got 1s and it's got 2s. Also, it's in the p block, so its highest energy electron should be in a p orbital, and it is. Okay, fluorine F9, again, make sure this adds to 9, 2, 4, 6, 8, 9. It should have 2 shells. It should have 2, 4, 6, 7 in the outer shell. Sodium, it's in period 3, so I should now need my N equals 3 energy level, and I do. I can see that my electrons add to 11. It's an S block. Okay, so its highest energy electron should be in an s orbital, and it is, and it should only have 1 electron in its outer shell, which it does. Beryllium is in period 2, group 2. Okay, 4 electrons are accounted for. It's an s block element. It's got 2 electrons in its outer shell, and it's got 2 periods. So just do those checks and make sure that you've written them correctly. In 5a, I tell you, you don't need to use the P, you can use the P shortcut. Again, just make sure this adds to 16. Make sure you've got 3 energy levels because sulfur is in period 3. Make sure you've got 6 electrons in the outer shell. Magnesium, these should all add to 12. Nitrogen, these should add to 7. Chlorine, these should add to 17. Please do these checks and make sure you're writing them correctly. In question 6, I tell you to use the noble gas shortcut as well. So the first one is silicon. You see silicon is here. The noble gas above it is neon. So I write down neon, and then I put up with 3s2, 3p2. When I'm doing this and I've written down neon and I want to know where to start, I know I got 1, 2. I'm in the 3rd period with silicon. Okay. I know that the s orbital is totally full. So the s orbital in the 3rd energy shell is going to be 3s. So my 3s is full, so it's got 2 electrons. And then I'm moving into the p because I'm a p block element, and I've got 1, 2 electrons, so I've got 3p2. Chromium, this is one of our exceptions. So again, I'm going to write down argon because that's the noble gas in the period above chromium. And then I have got 6 electrons to assign. Usually it would be 3d4, 4s2, but we've seen chromium is an exception, and those 6 electrons are split between 3d5 and 4s1. You need to pay attention to chromium. Aluminium is as follows. Manganese, again, I'm using argon. Once I've used argon, I know I've assigned 18 electrons, and manganese has 25 electrons, so I've only got another 7 to go. The first 2 are going to go into the 4s, and then I've got 1, 2, 3, 4, 5 to go into the 3d. So it's going to be 4s2, 3d5. It doesn't matter if you wrote these 2 the other way around, although typically you do put the 4s at the end, even though it fills first. Copper is another exception, okay? You've got 11 electrons, so after argon, which is 18 electrons, you can see that copper, you've got 29, so you've got another 11 electrons to assign between the 4s orbitals and the 3d orbitals. Usually that would be 4s2, 3d9, but copper is another exception, and it's actually 4s1, 3d10. Arsenic, okay, it's all the way over here, so I'm going to write down argon, and then I've got another 15 electrons to assign, okay? Those 15 electrons, I can see that my s orbital is full, and I can see that that 3d is going to be entirely full, okay? Arsenic is in a p block, so I know that the 4s and the 3d are going to be full, so I'm just going to go 4s2, 3d10, and then I've got 1, 2, 3 electrons left to go into the p orbital, so it's going to be 4p3. Then iron, again, I'm using argon. I've got 8 electrons to assign, and it's going to be a 2-6 split, 4s2, 3d6. In question 7, I'm doing ions. Again, when sodium loses 1 electron, it's got the same electron configuration as neon. When bromine gains 1 electron, it has, okay, so bromine, the noble gas above it is argon, and then I need to write all of this out. And I can see for krypton, okay, which is what bromine's going to look like when it has an extra electron, this whole fourth shell is going to be totally full, which means I'm going to have a full 3D, a full 4s, and a full 4p. When beryllium loses 2 electrons, it's just left with 1s2. You can write this as helium, but the shortcut isn't really needed here. When copper loses an electron, remember copper was 4s1 3d10, and that electron is going to come out of the 4s1 because 4s is higher in energy when they're both full. Okay, copper, you're going to be left copper 2+. Okay, remember copper can form more than one ion. The transition elements don't follow the noble gas configuration rule. Okay, they don't just lose electrons to have a full outer shell. And copper can lose 1 electron or it can lose 2. Iron is the same. Iron Fe2+ is going to look like this. Fe3+ is going to look like this. Again, you're taking those electrons out of the 4s before you're taking them out of the 3d. Question 8 asks me to identify atoms. There's a few different ways you can do this. The first way you can do it is just look at neon, okay, see how many electrons neon has, and then add on another 6. So I would go to my periodic table, I would see neon has 10 electrons, and then I would see that I have another 6 electrons. I've got 2 and 4, 6. 10 and 6 is 16, and then I go to my periodic table and see that sulfur has 16 electrons, therefore it must be sulfur, okay? The other way I can do it is I know it's going to be in period 3. I know it's going to be a p block element, so if I go to period 3, 1, 2, 3, it's got 4p electrons. If I start with the first p block element, which is aluminium, and count across 4, 1, 2, 3, 4, I end up with sulfur. So the first answer is going to be sulfur. The next one, again, neon, we said 10 electrons, another 4 electrons means it's going to be silicon. So silicon is going to be your answer. For the next one, you've got argon and another 2 electrons. So if I go to argon and then I go another 2 electrons past argon, I get to calcium. Now I've got argon and I'm going 6 electrons past argon. So I go 1, 2, 3, 4, 5, 6, and I end up with chromium. Argon, this time I'm going 9 electrons past argon. So it's going 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm ending up at cobalt. Then it's argon and I'm going 11 electrons past argon. That's going to take me the whole way up to copper. Argon, and I'm coming the whole way over here to 4p4. So rather than counting the whole way across, I know my 3D is full. I've got a p block element, so I'm going to come across here. And I'm going to start my first p block, which is gallium. We're going to go 1, 2, 3, 4, and I'm going to get selenium. Okay, it's 4p4, so I know it's my 4th p block element. 1, 2, 3, 4, it's going to be selenium. And then the last one, I can see that entire that entire 4th energy level is full. 3d10, 4s2, 4p6, which means the answer must be krypton. Identify which electronic structure belongs to N3-. Okay, so when nitrogen gains 3 electrons, it's going to have a noble gas configuration. So I'm looking for something that has a totally full shell. And when I look at my possible options, 2s2, 2p6, that's totally full. 2s2, 2p3, that is not full. 2s2, that is not full. So straight away, I know my answer is going to be A because I'm looking for a full second shell. If you wanted to do it another way, nitrogen usually has 7 electrons. It's gained 3, so you're looking for 10 electrons in total, 2, 4, 10. Okay, which electronic structure belongs to zinc 2+? Okay, zinc is here. Okay, it's got 30 electrons. If it's losing 2, it should now have 28. So you can add them up and see which answer gives you 28. Remember, argon itself accounts for 18. So you're looking for another 10 electrons. So you can see that B and C are both giving you another 10 electrons, but you have to pick the correct one. When the transition elements are forming ions, they're losing the electrons from the 4s first. So it's going to be C, 3d10, 4s0. And the last one, selenium 2-. Selenium is here in group 6. When it gains 2 electrons, it's going to form krypton. Same electronic configuration as krypton. So again, I'm looking for an entirely full 4th shell. So I've got argon. I should have 3d10, 4s2, 4p6, which is going to be here. It's going to be B. Okay, you can add up the number of electrons that you're supposed to have. You will see that it's supposed to have 36 electrons. The argon accounts for 18, so you need another 18 electrons. 10 and 2 is 12 and 6 is 18. Okay, so B is going to be your correct answer there.